Hello again. This is video number 2 for solving simultaneous equations, and in this video I'm going to show you how to solve simultaneous equations where we need to change one of the variables. When we look at this pair of simultaneous equations, we've got 3x add 5y is 51, x add 4y is 38. So we don't have a common coefficient for the x's, we've got 3x and 1x, and we don't have a common coefficient for the y with 5y and 4y. But if we triple the second equation, then we would have 3x in both equations. So my next step is to multiply everything in that second equation by 3. So x times 3 is 3x, 4y times 3 is 12y, and 38 times 3 is 114. A really common thing to do here is to not multiply everything by 3, so do watch out for that. I'm going to keep the top equation as it is because it's already got 3x in, but I'm going to write it underneath the one that I've just made because 12y is bigger than 5y, so I'm going to leave that on the top. It doesn't matter if they're the other way round, but I do know now it's going to make my next step a little bit easier because looking at my x's, 3x take away 3x is nothing, so by subtracting we eliminate that variable. Now in the middle, 12y take away 5y is 7y, and that's why I wrote them the other way around, so that would be positive. And then on the right hand side, 114 take away 51 is 63. If 7y is 63, dividing both sides by 7 gives me y is 9, and that's my first solution. From here on through, we use exactly the same steps as we did for the easier questions. We then substitute to work out the other variable. I'm going to use the second equation, the original one, because it's only got a single x in, so that's the easiest one, but it doesn't matter, you could choose either, or we could even go with the one that we've got by multiplying by 3, it doesn't matter. But using this one, x add 4y is 38, well 4y, 4 times 9 is 36, so we get x add 36 is 38, and so subtracting 36 from both sides, x is equal to 2. There's my second solution. The final step again is the same as we had for the easier questions, and that's to check that our solutions work using the equation that we haven't already used. So I've got to use the top equation here, 3x add 5y is equal to 51. 3 times our x value, 3 2s are 6, add 5 times by our y, 5 9s are 45, 6 add 5 is 51, and so we've got the correct answer. So just to go through again, we checked the variables, we noticed that by tripling the second equation we'd have 3x's in both. Rewriting those equations out, we would then had a set of equations in the same style as the easy questions that had a variable the same, and we solved from there. I've got a second example, same idea. By starting with comparing the coefficients, I've got 5x and 3x. They're not the same, and it's not easy to make those the same. But looking at the y coefficients this time, if I double 3, I get 6. It doesn't matter that one's positive and one's negative. We're just looking just at the values. So I start by doubling my top equation. 5x times 2 is 10x. 3y times 2 is 6y. And 43 times 2 is 86. Make sure that you multiply all three terms by whatever value you're multiplying by. I'm going to keep the second one the same. So 3x take away 6y is 18, and now I've got 6y in both, I can go ahead and solve these in the same way that I did before. Because I've got 6y and negative 6y, I need to add the two equations together so that we have 6y add negative 6y is nothing, and thus eliminating the y variable. Doing the same with the other terms, 10x add 3x is 13x, and 86 add 18 is 104. If 13x is equal to 104, we divide both sides by 13 to get our value of x, which is 8. And there's our first variable. From here on through, it's the same steps. We substitute to find our second variable. I'm going to use the top equation. 5x add 3y is equal to 43. X is 8, and so 5 times 8 is 40. Add 3y is equal to 43. Subtracting 40 from both sides tells me that 3y is 3, and so y must be equal to 1. The final step, as always, is to check our answer using the other equation, the one we haven't used. 3x take away 6y is equal to 18. 3 times 8 is 24. 6 times 1 is 6. And 24 take away 6 is 18. So we know we've got it right. And that's the end of video number 2, solving simultaneous equations where we have to change one of the equations. Video number 3, we're changing both equations to make one of those variables the same.